All right, hopefully your picture looks something like this. Somewhere you need a river. Some of you probably got more rivery in your river. And then we have another, we're doing fencing again. We want a rectangular plot that borders the river. If you do not fence the side on the river, okay, so my picture is going to look like this. So your picture should look something like. Okay, so keep in mind, there's no fencing here. I need fencing here, here, and here. It is a rectangle, which means this side is going to be the same as that side as far as length. So again, they've given me fencing, which means they've given me perimeter. Normally, I would say, okay, well, my perimeter is 104, and I would normally say, that means I have this. This is not the correct way to write this problem. Why not? Yeah, because one side, I don't have 4 pieces. This represents 4 pieces of fencing. I only have 3. It doesn't matter which one you call X and Y. If you want to be consistent with me, I always do the short one as X, just so you know. So I would call that short side X. So if that's X, this is X, which means that one's Y. So my perimeter for this problem, I have 2 X's and only 1 Y. You would still get it correct if you did 2Y plus X. You just would have, each of your sides would be defined differently. So I still took the perimeter formula. I just had to adjust it because I don't have 4 sides of fencing this time. And now you're going to do everything the same. I'm going to let you work through that one. All right, this was number 6. So I'm just going to scan through the work here. I guess I'll go through the little laser pointer there. So you had perimeter. Perimeter is 2x plus 2y. Get y by itself. That brings you to here. You're trying to maximize your area. Area is x times y. You're going to replace that letter y with its new definition from up above, 98 minus x. Distribute your x. We like to have our quadratic term first, so you just reverse the order for those terms. And now you're doing completing the square. You had to factor out your negative, which means divide both of those terms by a negative. You end up with negative 98x. There should be a little x there. Let's see if it'll let me add that in. X. Okay. And then you do your steps off to the side. Take half of that middle term and square it, and that gave you 2401. When you add 2401, here, remember that there is a negative that you have to multiply it by. That tells you what to do on the left side. So that's why I have negative 2401 there. That factors, after you've done your steps, the negative stays outside. X minus 49, because you got a negative 49 when you took half. Move your 2401 back over and it becomes positive. So this 2401 is the area. 49 is the x-coordinate of your rectangle. So to find the y-coordinate of your rectangle, you have that formula for how to find y right there, 98 minus x. Plug in 49, and that tells you that y is also 49. So the dimensions are 49 by 49. Should have been recording that. Okay, well, we're doing it now. Looking for a product, that's multiplying 2 numbers. The sentence they gave us is 2 numbers whose sum was 32, so we added. Got y by itself. Now plug that value in. Instead of x times y, we have x times this new definition for y. Same thing you did before. Distribute that x. I'm going to stop talking. I want you to finish this one. Here? Yeah. You're either going to have to switch places here or you're going to have to switch it with 2 terms. So it doesn't really matter which. As long as you know when you move it, you keep the negatives. The negative with your x. Okay, don't peek up here until you're done. No peeking or until you're mad. It happens. When you write your vertex, no.